So the next form we're going to look at is factored form, specifically trinomial factorization. So from factored form, it's easy to find the x-intercepts, the y-intercept, the line of symmetry, the turning point, and the nature of the function. We'll start with finding the x-intercepts because in the other forms it can be more difficult to find these. You can't really just do it by inspection like you can with factored form. The x-intercepts are where y equals 0. So y is 0, that's where the 2 points are found. So we need this to be 0. For that to be 0 and to solve the equation we need to use null factor law, implying that that has to be 0 or that has to be 0. For that to be 0, x plus 3 must equal 0 or x minus 1 must equal 0. And to make this bracket 0, just by looking at it, we can tell that x must be negative 3 or x must be 1, which is what I did there. To find the turning point's a little bit more difficult than turning point form. We have to find the midpoint between these 2 points. And that will give us this, and then if we substitute this into the equation we can find the y value. So here I've added them together and divided by 2, so I find out that this point here is minus 1. Substitute minus 1 into this equation, and that tells us that y is minus 4 when x is minus 1, which is that point there. And we know our line of symmetry because it's the same as that. We know that a will be 1 in this case. That's the value of a outside the bracket, indicating that the function will be concave up. And we can tell that because we multiply x by x, we're going to get a positive x squared in our standard form. And we can find the y-intercept by substituting in x equals 0. If I substitute in x equals 0, it will tell me this point here into this equation. And that's what I did there. I put 0 in here, multiply them together. 3 times negative 1 gives me negative 3. Now, converting from standard form to factored form, here I go again. Standard form to factored form, I can use trinomial factorization or the quadratic formula. We're going to start with trinomial factorization. So if a equals 1, if it's just x squared plus bx plus c, as opposed to some value times x squared plus bx plus c. Where a equals 1, find the factors of c that add to b, find the factors of c that add to b, rewrite the equation with the factors from 1. Now, this won't always work, but when it does, it's very quick. So, factors of negative 3 that add to 2, negative 3 take 1, if I add those together I get 2. I then just write them in factored form. X equals x plus 3, x take 1. And there we go. I don't know what that was underneath, but I can delete that now because it's not necessary. Now if a is greater than 1, rather than just finding the factors of c, we have to find the factors of a times c that add to b. We're going to split the middle term, or the term where b is the coefficient of x, into the same factors that we found from 1. Factorize the first 2 terms and then the second 2 terms, and then factorize the second time. Now, sounds complicated, but when you're doing it, it's quite simple. We start with 2 times negative 12, wrote it up here, negative 24. Consider the factors of it that add to negative 2. In this case, negative 6 times 4 will add to negative 24, will add to negative 2, and negative 6 times 4 is negative 24. The factors we're looking for, and the sum that we're looking for. Now what we do is we split this term here into these factors. So you can see here I've still got the 2x squared, I've still got the negative 12, but I've split negative 2x into negative 6x and 4x. That still adds to negative 2x. This equation is still equal to this equation. Then what I do is I factorize the first 2 terms. I end up with 2x, x take 3, and I factorize the second 2 terms, 4 times x take 3. Then you'll see that these have a common x take 3, so we can factorize out again. Here's x take 3, and we end up with 2x plus 4 in the second bracket. Now we've fully factorized this expression up here. Now there are some common errors with factorization. And the first thing to understand is that when we're looking for the factors, we're not looking here for the null factor law. Blah. What is what would you do here? Oh, so what's important here is that we're looking for where the graph crosses the x-axis, where y equals 0. So it's not just taking the negative of what's in these things. Now, to find that corresponding value of x where y equals 0, substitute in 0 for y, which is what I've done here, and then use null factor law to solve. So we'll want to know when this bracket is equal to 0 and when this bracket is equal to 0. Now, where the coefficient of x is 1, that's quite easy. You just take the negative of whatever that is. But where it's not 1, in this case it's 2, you have to think about it. Where x take 3 equals 0, x equals 3, just like it was up here. But now positive. In this case, we've got 2x plus 4. So we want to know when 2x plus 4 is equal to 0. Solve this equation, 2x equals negative 4, x equals negative 2. And I suppose the point that I'm trying to make is it's not always the negative of whatever's here. It's when this equals 0 or when this equals 0. Now, not all equations can be factorized with trinomial factorization techniques, where factors of a times c cannot easily be found that add to b. So when this times this can't be found easily to equal that, or the sum of the factors, you have to use a quadratic formula. So you have to be able to do this fairly quickly in order to determine whether it's possible or not, because the quadratic formula takes a fair bit more time to do, and usually it's worth checking that trinomial factorization isn't possible first. There you go. Thanks, everyone.